Talking about the different sorts of triangles, we have angle, angle, side, angle, side, angle. Both of those can be totally solved using the law of sines. Side, angle, side is unique, but the orientation of the sides and the angles make it so that you cannot solve the triangle using the law of sines. You have to use what's called the law of cosines, which is a bigger problem. Law of sines is easier. No, not yet. So we're going to talk about angle, side, side. This is your favorite one, right? Angle, side, side. In the past, if you had angle, side, side, you said not congruent, which wasn't necessarily true. Because most of the time it is actually congruent. Some of the time it's actually two different triangles, but sometimes it's none. So let me show you. This is just a review. So if I had an angle, let's say 70 degrees, and let's say that this side was 10, okay, I would need another side. I know the angle and I know one side. Now I need to know the third side. I'm not recording, am I? I am recording. Great. So this third side would be this side over here. Is it possible for that third side to equal 1 foot? No. Why not? Okay. Now can it be 1 foot? No, because if I draw a radius 1 foot circle around that, it just simply is too short. It's got the Amy disease. In my last class, I reflected it on me because I was the shortest person in the room. Touche. Okay, so how long does it need to be? Well, let's figure this out. So let's assume that 1 foot works. Okay? So let's do the law of sines. The sine of 70 over 1 is equal to sine of, I don't have the name, but I could call it A, over 10. Now, I'm solving for A, so what would I do? Times by 10. Times this by 10, and I have 10 sine of 70 equals the sine of A. Okay? 10 sine of 70, and I'm dividing by 1, right? But I'm not going to bother. So I get 9.39. How do I know this already doesn't work? Right. Can the sine of A equal 9.39? No. So how long does A need to be in order for this to work? Bigger than 9.39, right? If I divide this by 6, is that going to be enough? 9 divided by 6 is greater than 1. So it has to be bigger than 10 sine of 70. Okay? So let's say that it's 11 feet. 11 feet. So I'm going to 10 sine of 70 divided by 11. I get 0.85. Does the triangle exist? Yes. How do I figure out what angle A is? Take the inverse. So I'm going to draw this side here. This is 11 feet, and I'm looking for angle A, which would be right there. So I invert, and I get 58.6. So 58.6. But is there another triangle that works? Well, you'll see, let's say I just start making this a little bit bigger and a little bit bigger. None of those are triangles, right? There is one triangle that hits exactly once, in which case this angle and that angle would be the same size. It's an isosceles. My picture's bad, but yeah. No, it would. Well, it's not really. Well, don't trust my pictures. It doesn't matter because it's not going to happen. So, but if I did one that was a little bit bigger, How many triangles are there? 2, because there's an intersection here and there's an intersection here. So I would have this picture and I would have this picture. And that side matches this side, and this side matches that side, and that angle matches that angle, and I have angle side side, right? Well, what if I kept making bigger pictures? Eventually, it's too big for 2 triangles, but it is big enough for 1, right? So how do I tell? I've already eliminated all of the non-possibilities. How did I do that? By the sign being less than 1. So when I got that 0.8, that guaranteed that it hit. How do I tell if it hits twice? Well, it's actually really easy. If you look at the picture, so this was 70, and this was, what, 50, 58? Okay, if I swing that side around, and it hits again, then this angle has to equal that angle because those 2 sides are equal. It's an isosceles triangle. So that would be 58. Now, if this is confusing, don't worry. It's about to get really easy. No, you're getting close. What's that angle? It's the supplement to 58, which is 122. Can that happen? So I'm looking at this little triangle here. That angle is 70. This angle is 122. Anybody see a problem? That's not a triangle. We've already broken the 180 rule. So I don't want to do this test every time. Can we just compare this angle to that angle? Because that's really what we did. We compared the supplement of this to that. So how big does this have to be before the supplement starts being small enough? Yes. What if they were equal? 70, 70. If I swing that over, this is 70, so this would be 110. 70 and 110. Well, think about this. If this angle equals this angle, then this side equals this side, and when I swing it, it's going to land right there. So I have that, and I have that right on top of it, with a 70-degree angle, a 110, and a 0 up there. So here's the rule. If the new is bigger than the old, so if this is big, then the supplement is small, which means there are 2 triangles. If the new is smaller than the old, then that means if this is small, then the supplement is large, which means the second triangle doesn't exist, so there's 1 triangle. But what if the new is equal to the old? Then the second triangle is in fact a straight line, so this gets an equal to. Okay? So that's how you tell. So if you look on 19 to 24, all it's asking is 0, 1, or 2. That's it. Okay? But the ones above that say solve the triangle, which is easy, but sometimes there's a second set of answers that you didn't think to look for. So take a look at number 11. Yeah, we'll do that right here. Now, you can do this whole thing without a picture. I'm going to draw a picture off to the side. You don't really have room for a picture, so you might need another paper. So I prefer to always set it up in this mode because I'm used to swinging this side over. So I'm going to say this is 70, and because that's A, then this is 25, right? And then which side would have to be 26? Well, it doesn't matter, but with my arrow, it would have to be up here. I prefer to always make it look like this because sometimes realizing which side moves is harder than you think. So always put your angle here, and then whatever side is opposite your angle there, and then the other side there. That's how I always do it. So we need to set up the law of sines. But before we do that, what answers do we still need to find? What three missing parts are there? So we're looking for angle B and angle C and side B. Which one can we figure out first? C. Everybody agree? We can't touch B until we can find the angle C, which then we can find angle B. Okay, so angle C, sine of C over 26 is equal to the sine of A, or 70 over 25. Everybody okay with that? Multiply by 25. So 25 sine of 70 divided by, oh wait, yeah, divided by 26. What are we hoping for? Well, okay, if you're really cynical, you're hoping for a number bigger than 1, because then you're done, right? So, let's see. Oh, how many answers are there? At least one. Do we know if there's two? Not yet. Okay, we don't quite know if there are two. There might be, but we're not sure. Okay, so if we swing that over, oh wait. So how do we find the angle? Take the inverse, and we got 64. Wait a minute, did I screw up? I got it upside down. Sorry. Oh man, I'm embarrassed. Anyway, it's 26 sine. Okay, sorry. 26 sine of 70 divided by 25. Now take the inverse. And we get 77.7, which means two solutions. Okay? Do you want a hint? There's a really easy way to tell if there's only one. Look at 25. If I swing 25 over, is it going to hit this bottom side? Maybe, maybe not. But is there a number I know is going to miss? Anything bigger than 26 can only have one number, right? Can we guarantee that 25 even exists? Not from the picture. We have to look at the numbers. So if this was 27, then automatically the answer is 1. If okay, here we go. This way you'll remember. If your second S is bigger than your first S, you're number 1. I don't know. If your second S is smaller than your first S, then you might be number 2. All right. I need to go back to school. Okay, but just looking at this, the fact that 25 is smaller than 26 means we need to test it. If it would have been 27, there's no need to test. It has to be 1. Because if this was a little bit longer, if I swung it around, it would miss that point entirely. Okay? All right, so let's finish out this list, and then we'll look at the other list, which isn't as tough as you might think. So here we have 77.7. How do we find B? We could do the same thing. No, we couldn't, because we don't know little b. But we know the angle sum of a triangle. So 180 minus 70 minus the answer is 32.2. Everybody okay with that? Now that we know angle B, we can find side B by using the law of sines again. All right, so sine of 70 over 25 equals the sine of 32.3 over B. Are you guys good enough to just plug this in the calculator? What's it going to, I'm not, obviously, I get it wrong. What is it going to be? 25 sine of 32.3 divided by the sine of 70. So 25 sine of 32.3 divided by 70. Oh, the sine of 70. So that tells us that little b is 14.21. Now, the second triangle, it's not tough, but you need to remember one thing. If I swing this, and this is 77.7, what is the supplement angle? 180 minus 77.7. So now this is angle C, right? Because angle C is this one here. And when I slide this side over, it's that angle there. But I don't know that one. I know this one. So the supplement is 102.3. So I need to make a new list. Angle B, angle C, and little b. And angle C is now 102.3. How do I figure out? Right, the second triangle, which is called the ambiguous triangle. In the ambiguous case, the angle you calculate for the second triangle is actually the supplement of the angle you're looking for. Okay? So I need to do 180 minus 70 minus the answer again, 7.7. And the nice thing is, now all I have to do is recalculate little b, but I already have the formula here. I just need to change one number. This is unchanged. This is unchanged. I just need to change that to 7.7. So if you look at your calculator, I've already got it up here. So I'm just going to go back. And I'm going to I'm going to change this 7.7. So that is the new B, 3.56. Okay, Travis, where are you confused? I wonder if it's going to get through. I doubt it. This microphone's probably not that good. I can hear. Can I hear it? Oh, that one. Yeah. Okay. I see what you're saying. Okay. So do you want to see another one? Okay. Let's do 13. So sine of 145 over 33 is equal to the sine of b over 7. Now, well, I'll be smart in a minute. Let's be dumb. 7 sine 145 over 33. Okay. Does this triangle exist? Wait a minute. What did I do wrong? 33. Sorry. Okay, but that's good. If we would have got 1.3, the answer is no triangles, right? But your math teacher doesn't know the difference between 3 and 33. So now does it exist? Yes. So if I take the inverse, that tells me what? What is 6.9? Angle C. So angle C is 6.9. I now need to find angle, no, wait, not C, B. Angle B is 6.9. I now need to find A, and once I find A, I can find little a. But is 6.9 bigger than 145? No, so we have one triangle. Because what's the supplement of 6.9? Really big. Is a really big number and 145 going to make a triangle? No. But I'm smarter than that. Right? I had 145, I had 7, and I had 33. Could there possibly be two triangles? No, because it actually looks like this. If I swing this side down, is it ever going to touch this side again? No. So Oh, yeah. So anyway. Okay. That should be everything you need to know to finish the worksheet. On the first group, you're solving the triangles, which is weird because on the second group, you're just saying 0, 1, or 2. And then the last group is just a review of the law of, or the area formula using the sign. Okay. Good luck.